All right, so we're talking about the last type of word problems we're going to deal with this unit. They're pretty tough, but hopefully some science stuff you've done will help you with this. So distance, speed, time stuff, we're going to talk about the formula. The formula is distance equals speed times time. The way that I remember this, there's a little triangle that scientists like to draw, whatever. When I think of speed, I think of those signs you see on the highway, right? They say how fast you're allowed to go, whatever. Those are always written in kilometers per hour. So when I think of this, if I needed to figure out distance, speed, and time, the speed is always something kilometers per hour. So let's say it was 100 kilometers per hour. If I wanted to know how far you go, you would take that and you need to multiply it by however many hours you drive for. So let's say you drove for 2 hours. How far do you go? Well, obviously it's 200. That's the formula that we're using. The total distance is equal to whatever the speed is times the time that you're given. Be very careful as well. The speed will usually dictate the units we're using. In this case, it's kilometers and hours. So the distance would be in kilometers. The time would be in hours. If it gives you a question with minutes or something, you might have to convert. So that formula is going to be really important. Let's do some practice questions to see how to set these up. So in this question, the student drove a bunch of distance in that many hours. This included a stop and a stop. So right away, when I notice these stops, we're dealing with like her driving. So the stops aren't actually part of the total time. So just what I'm going to do at the start, it was 16.5 hours. I'm going to take away the 1 hour stop, and I'm going to take away the 30-minute stop, which, be careful, unit conversion, that's 0.5. So that means her total driving time was actually 15 hours. Okay? That's the time. Now, it gave an average speed for the divided highways and an average speed for the non-divided highways. Cool. And it says how much time did she spend on each. So that's what we're trying to find. So again, we're going to set up our let statements. So let x represent time on, we have the divided highways, and then y will represent time on non-divided highways. Blah, blah, blah. Okay? So those are the two variables we're trying to find. So we need to write two equations. The first one's going to be the easiest. We have time, and we already know the total time. So we can just say x plus y equals 15. If I know the hours on this highway and the hours on this highway, the total is 15. First equation done. Second equation is a little trickier. We have to use basically all the numbers they gave us. Okay, so she's averaging 100 kilometers per hour and 75 kilometers per hour. So we're going to write this equation this way. Let's do a different color. So I want to find the total distance. Okay, 1, 2, 4, 5. That's the total distance. In order to write equations, I need to do something like, oh, well, if I do this distance plus this distance, it will give me the total distance. That makes sense. The first distance is going to be from these highways. The second one's going to be from these highways. The only problem is the numbers they gave us are not distance. So we need to create a distance unit. How far does she go on each of these highways? So let's use our formula. Okay, distance equals speed times time. So in order to find the distance that she goes on these first highways, I'm going to put the numbers in. So the speed on those first highways was 100. And then the time she drove for, I don't actually know, we called that x. So it's just going to be distance 1 is 100x. So this is 100x. For the other highways, she went a different speed, I think it was 75. And again, we don't know how long she drove for, just y, but then we know the total. So what you'll notice in this equation, we used all the same units, and the one we figured out was whatever total it gave us. Okay, so we used the total time over here, and we had time. Here we had distance, so then we had to write distance plus distance equals distance. We didn't have any distance units, so we needed to create it using what we had, which was speed and time. A lot of questions are going to be set up this way, where one equation is one unit or one type, and one is another, and you just need to convert using the formula we talked about. Let's do the second one. It's a little trickier. Okay, so in this case, we have a boat. It's going downstream and then it's going upstream. One thing you have to understand when you're on a boat, if you're just sitting in a boat and let's say it has like a motor, right? It's pushing you forward. But sometimes the water has a current as well. And so if you're going the same direction as the current, you're going to go faster. That's a boost. That's addition. Whereas if you're going the other direction than the current, you're going to go slower. because it's whatever your speed is, but you have to take away the force pushing you. Okay, so our two equations are going to be the downstream one, which is when the current is pushing you, and then the upstream one, which is when the current is in your face. Okay, the same thing is true with like airplanes. So let's set up our two equations. The boat took 3 hours, so trip 1 was 3 hours and 36 kilometers. Trip 2 was 4 hours and still 36 kilometers because it was the same boat trip. So we need to set up two equations. This one's going to be adding to get the total. This one's going to be subtracting to get the total. Let's set up our let statements. So the two speeds it wants us to find is the speed of the water and the speed of the boat. So let B represent boat speed. Let C represent water speed or current or whatever you want to call it. Okay, so I am not going to write boat speed plus current speed equals this, because the problem is I don't actually know like the total speed we have. All we have is these two things, the time and the distance. So we're actually going to set it up as distance plus distance plus equals distance. We got to use our formula, distance equals speed times time. So in this situation, the speed, we got boat speed and current speed, and then the time was 3 and 3. So this represents, after I go for 3 hours, at the speed of the boat, whatever it is, how far do I go, plus how far would I go from the water pushing me, gives me the total distance I went. On this side, the same thing's going to be true, except it's 4 hours of boat, 4 hours of water current gives me the total 36. Now, some students will try and set this up this way, and they'll use the total time. The only problem with this, if we rearrange our formula to make it time is equal to distance over speed. I don't want to do this for this question because the speed was a variable. When you divide stuff by variables like x and y or b and c, so this would be this, you get weird numbers because you're dividing by different amounts, and you're not going to get straight lines, which is what we're doing in this unit. You're going to get curvy lines. So if you ever find yourself trying to write an equation like this with variables on the bottom, don't do it. Okay, try and write it a different way, like we did over here. So, and same as the other unit, the units we've done so far. I have two equations now. Now you would plug them into Desmos or substitute elimination to find the point of intersection, so you can find what x and y is. That's it. This section of the unit is very difficult, but if you understand the idea, you're going to increase in speed or decrease in speed if the boat is pushing you or going against you, and you know you're going to write two equations. It works very similar. That's it.